The moon often seen as something beautiful and romantic, just there to admire. But what if it suddenly disappeared? No more seasons, no more tides, no more life as we know it. And this isn't science fiction. It's a scientific simulation that could one day become reality. Stay until the end to discover why, without the moon, Earth could become a dead planet. You're listening to Astronomy Universe, the channel that decodes the mysteries of space through stories you've never heard before. Hit subscribe if you're ready to step off Earth and explore the cosmos with me. When night falls and the dim lights of the city fade away, one thing always remains silent, gentle, shining in the sky, the moon. It is not just a silver orb floating in the dark. It is the silent witness to human history, the ancient guardian of Earth. The moon is about 384,000 kilometers away from Earth distant, yet close enough to influence life down below. According to the most widely accepted theory, it was born from a massive collision more than 4 billion years ago. A primordial planet named Theia slammed into early Earth, and from the ashes of that violent impact, the moon was born like a twin sibling, cast away into the sky. For millions of years, it has quietly fulfilled a crucial mission, keeping Earth stable. Like a weight that steadies a spinning top, the moon holds Earth's axial tilt within safe bounds around 23.5 degrees. Without it, our planet could wobble like a boat tossed by turbulent seas. But its role goes beyond mere physics. The moon has been an endless source of inspiration in poetry, religion, and mythologies across the globe. Ancient peoples called it the goddess of the night, a symbol of distant love, of birth and rebirth. In many cultures, the lunar cycle was even seen as a biological clock for humans linked to menstruation, sleep, and emotion. Yet, these are only the surface truths. The moon's true role is far deeper. It drives the tides, those vital movements that breathe life into oceans, nourish coastlines, and help cool the planet. It shields Earth from chaotic changes in the solar system. It is an invisible shield, a silent axis, an ancient light that has never gone out. But what if, one day, the moon suddenly vanished? A peaceful evening, you're out for a walk, gazing up at the sky, expecting to see the radiant full moon. But tonight, there's only a vast, gaping darkness, no clouds, no fog, no moonlight. It has vanished. No warning, no explosion, no sound. Earth's only natural satellite disappears as if someone pressed a cosmic delete button. And that's when the nightmare begins. Hypothetical scenario 1. The moon explodes. Imagine this. Instead of simply disappearing, the moon is struck by a massive asteroid or rogue object from the Kuiper Belt, hundreds of kilometers wide. The collision occurs at tens of thousands of kilometers per hour, shattering the moon into millions of pieces scattered across space. Within just a few hours, observatories detect an unprecedented phenomenon, a massive ring of lunar debris encircling Earth, reflecting sunlight like a fiery halo in the night sky. No longer a single moon lighting the heavens, but thousands of flickering fragments, flashing like cosmic distress signals. The night sky has never been so bright, but it is not a light that brings life, it is a warning of destruction. Immediate consequence 1. Meteor showers and cosmic collisions. Some of the larger lunar fragments fail to maintain orbit and begin plummeting toward Earth-deadly meteors from the sky. Each piece, even the size of a bus, unleashes a blast comparable to a nuclear explosion. They slam into oceans, sending tsunamis to devastate coastlines. They punch into deserts, shaking cities to their core. Artificial satellites responsible for everything from telecommunications to GPS are obliterated as they collide with lunar debris. The world plunges into a technological blackout. No communication, no navigation, no control. Space stations like the ISS are forced to evacuate immediately or face total destruction. Hypothetical scenario 2. A dust ring blocks the sun. If the explosion generates a vast cloud of lunar dust, that dust could slowly spread along Earth's orbit, forming a ring that dims the sun's lighten effect, similar to a nuclear winter. The sky turns murky. Daytime becomes dusky. Sunlight weakens. Trees begin to lose their leaves out of season. Photosynthesis falters. Global temperatures drop within weeks. An unnatural winter arrives, destroying crops and throwing ecosystems into disarray. The moon's disappearance isn't just an astronomical event. It is the first domino to fall in a global chain reaction. Psychological and social impact. No one knows what's happening. Emergency alerts flood the media. Some believe it's the end of days, fulfilling ancient prophecies. Religious fervor surges. Fear spreads. Masses flee to so-called safe zones, triggering chaos like never before. No moonlight, no signal, no direction, only confusion, cold, and the echo of isolation across a once peaceful world. You stand before the sea. The breeze brushes gently past you. The waves once rose and fell with perfect rhythm, but today, the ocean no longer breathes. For billions of years, the moon has been the silent conductor of the oceans. Through its gravitational pull, it raised and lowered the tides, creating essential biological rhythms for the entire planet. But when the moon vanishes, that rhythm shatters. Weakened and erratic tides. Without the moon, Earth still experiences tides, but they are drastically weakened. In its absence, the sun's gravitational pull becomes the dominant force, yet it only generates tides that are 2 to 3 times weaker than what we once knew. High tides now occur at noon across the globe, instead of following the moon's precise and shifting cycle. The rise and fall of sea levels drop to just 30–40% of their previous range. The ocean seems strangely still, a quiet that unnerves even the most seasoned fishermen. The sea has lost its rhythm, and when the ocean no longer breathes, all life begins to suffocate. Collapse of coastal ecosystems. Countless species, from sea turtles to coral reefs, horseshoe crabs to tiny fish, have evolved over millions of years to follow the moon's rhythm. They mate, spawn, migrate, and feed in time with the tides. When that cycle disappears, they lose their way entirely. Mother turtles no longer know when to return to shore to lay eggs. Fish become disoriented on their breeding journeys. Mangrove forests, marshes, estuary salt, reliant on tidal flow, begin to wither and die. And the impact ripples outward. Seabirds lose their food sources, larger fish lose their prey, and humans begin to feel a shift they cannot see but can clearly suffer. We often think losing the moon means losing beauty in the night sky, but noise the loss of life's most fundamental regulator, the breath of the sea. You might not see the moon every night, but you always live within its embrace, not through its light, but through its stabilizing force. When the moon disappears, Earth doesn't just lose a satellite. It loses the anchor that keeps it steady in the vastness of space. The moon, Earth's invisible balancer. Earth's axis is currently tilted at about 23.5 degrees, and this tilt is what gives us the seasons. Spring, summer, autumn, winter, they arrive on schedule because Earth's axis remains stable. And what keeps that axis from wobbling wildly is the moon. Every planet has an axial tilt, but not all planets manage to keep that tilt stable. Mars' cosmic neighbor has an axial tilt that fluctuates between 15 and 35 degrees. This leads to chaotic climate shifts, swinging from extreme freezes to searing heat waves without warning. And without the moon, Earth could face a similar fate, perhaps even worse. Axis instability, the onset of chaos. Without the moon's gravitational influence to stabilize it, Earth's axis could begin to tilt uncontrollably, shifting over cycles of thousands to millions of years. The tilt could swing anywhere from 0 degrees to 85 degrees, a catastrophically dangerous range. 0-degree tilt. No more seasons. The equator would always be blistering hot. The poles would remain in eternal freeze. Life would be restricted to narrow temperate zones. 45 degrees tilt. Polar regions would begin receiving intense sunlight for extended periods. Ice caps would melt rapidly, causing sea levels to surge across the planet. 85 degrees tilt. Earth would be nearly on its side. One half of the planet would face the sun for months on end, roasting under unlivable heat. The other half would drown in prolonged darkness, frozen in near-eternal winter. When the seasons grow extreme and lose their rhythm, agriculture collapses, ecosystems vanish, and humanity begins a migration born of climate. Planetary scale climate shifts. With an unstable axis, climate cycles would unravel completely. There would be no such thing as a winter every year or a June summer. One year could be a decades-long winter, followed by an equally prolonged, searing summer. Temperate zones could turn into deserts. Tropical regions might freeze from axial shifts. The North and South poles could alternate between burning heat and hellish cold. Worst of all, wind systems, ocean currents, and CO2 cycles would shatter. The planet could spiral into a runaway greenhouse effect, approaching the Venus scenario where Earth becomes the next Venus, scorched, toxic, and utterly uninhabitable, to zero-soidal collapse, humanity in global climate crisis. Coastal cities would be swallowed by rising seas. Equatorial nations would become uninhabitable with sustained heat of 60-70 degrees C, 140-158 degrees 5. Water scarcity, food shortages, resource wars, and climate-driven migration would push hundreds of millions from their homes. No asteroid required, no nuclear war needed. Just the loss of the moon and the plug is pulled on Earth's most precious balance, a stable climate. We think the ground beneath us is solid, but that's only true while the cosmos remains in balance. When the moon disappears, even the Earth's core begins to scream. The moon doesn't just influence tides. An axial tilt it also exerts a subtle but consistent gravitational pull on Earth's crust, creating what are known as Earth tides, gentle shifts in the planet's surface. This is like a silent planetary massage. When that stabilizing force vanishes, Earth's crust loses its pressure equilibrium, and the consequences can be devastating. Increased earthquakes from gravitational imbalance. Tectonic boundaries where Earth's plates meet, collide, or slide past one another are subtly regulated by the moon's rhythmic pull. Without it, built-up stress in these regions may no longer release in steady pulses, but in sudden, violent quakes. The risk skyrockets in vulnerable regions, like the Pacific Ring of Fire, Japan, California, Chile, the Himalayas, India, Nepal, Tibet, the South China Sea and Banda Sea regions. Cities once thought unshakable could be shattered by a single crack from deep below. ADE mass volcanic eruptions. When Earth's crust destabilizes, magma chambers quietly pressurized over millennia can erupt violently. Dormant volcanoes could awaken all at once, unleashing not only lava but also toxic gases, ash, and sulfur into the atmosphere. Sulfur dioxide, SO2s, from eruptions reacts with water vapor, forms acidic clouds, triggers global acid rain. Ash clouds spread for months, block sunlight, trigger a volcanic winter. The outcome could resemble the 1815 Mount Tambora eruption, failed crops worldwide, food prices soaring, and widespread famine. One supervolcanic eruption alone could push civilization back a century. Without the moon, this may not happen once, but many times over. True catastrophe doesn't begin with explosions. It begins in silence. The silence of leaves no longer reaching for light. The silence of forests forgetting how to breathe. And then, life begins to unravel, layer by layer. After the moon vanishes, if the explosion scenario plays out, a massive cloud of lunar dust could encircle Earth's orbit, forming a natural ring of debris. At first, the dust consists of microscopic particles light as ash drifting high in the atmosphere. But over time, it thickens, building a hazy shield that blocks sunlight. Plants can no longer photosynthesize. As light fades, plants lose the ability to photosynthesize. Without enough photons to convert CO2s into sugars and release O2s, the life engine stalls. This doesn't happen overnight, but within weeks, the world's tropical forests begin to wither. The Amazon, the lungs of the planet, fades into a permanent autumn, its green replaced by gold and decay. Marine algae and phytoplankton creatures responsible for producing up to 70% of Earth's oxygen begin to die beneath the darkened ocean surface. The global absorption of CO2s halts, causing greenhouse gases to spike and accelerating climate collapse. Earth once breathed through light. Now, it begins to suffocate in its own encroaching darkness. Oxygen drops, life withers. As plants cease to generate oxygen, the atmosphere's balance of oxygen and carbon spirals out of sync. Humans don't notice at first, but just a 5% drop in oxygen leads to fatigue, dizziness, and mental fog, a sharp decline in work capacity, difficulty breathing in, the elderly and very young. If oxygen levels fall below 15%, most mammal humans included can no longer survive. Lush forests become graveyards of bare branches. Humanity is forced to migrate toward rare sunlit zones, mountaintops or regions spared from the dust ring. But these places are few, remote, and utterly insufficient to support billions. From a cosmic disruption above, the chain of life snaps, and what seemed as strong as the oceans and old-growth forests turns out to be fragile beyond belief. After all these terrifying scenarios, you may wonder, is this truly possible? Could the moon, that eternal symbol, actually vanish one day? The answer is not entirely impossible. Modern science, through simulations by NASA, ESA, and major astronomical research centers, has posed this very question, and the conclusion is clear. The risk is extremely low, but not zero. When the moon is slowly drifting away. Currently, the moon is moving away from Earth at a rate of about 3.8 centimeters per year. That may sound tiny, but over time, it adds up. In the next 500 million years, the Earth-Moon distance could increase enough to significantly weaken the moon's gravitational pull, disrupting tides, axial stability, and even planetary orbits. If it crosses a critical threshold, the moon could eventually escape Earth's gravity altogether, like a lifelong friend slowly drifting away after years of growing distance. We once had total solar eclipses, but in the far future, that phenomenon may disappear because the moon will be too distant to block the sun completely. 140 possibility of cosmic collision. The universe is anything but peaceful. Millions of asteroids drift through space, and a single collision with enough mass and velocity could partially or fully destroy the moon. The Theia hypothesis, the idea that a Mars-sized planet once collided with Earth to form the moon, shows that planetary scale impacts are not mere theory, but recorded history. A future impact like that could create a field of lunar debris around Earth, triggering the very chain of disasters we've imagined. A vital orbital disruption from major cosmic events. If the moon were affected by the gravitational influence of a massive external object such as a passing brown dwarf star or a rogue planet, it could be knocked out of orbit, gradually drifting away from Earth, or worse, spiraling into a collision course with us. We live in a universe in motion, and in such a universe, nothing is truly permanent, not even the moon. There are things we see every day, yet we forget they exist until the moment they are gone. The moon does not emit light. It only reflects the light of the sun. And perhaps that's why it has become a symbol of humility and loyalty. For billions of years, it has never left Earth. Slow, steady, always present, not needing attention, only trust. It keeps the oceans breathing, the climate balanced, and Earth's axis steady like the compass needle of life. It's also the place where humans took their first steps beyond this world, the first milestone in our journey into space. If one day the moon were to disappear, we wouldn't just lose the soft light in our night sky. We would lose the steady heartbeat of the oceans, the seasonal balance of our climate, the biological roots of forests, seas, and breathable air, and above all, a piece of ourselves. Because the moon isn't outside of us. It lives in every heartbeat, in every dream, in every lullaby sung to a child, in every memory of love, of life, and of loss. If you've ever looked up at the moon, remember, you are witnessing a rare miracle in the universe. Something more fragile than you imagined, yet more enduring than any promise humankind has ever made. If this video stirs something in you, please like, subscribe, and share it with those you care about, so they too will know if even one satellite were to vanish, an entire world could fall apart. And tell us in the comments below, if the moon really did disappear, what would you miss the most? This is the end of our journey tonight, but I'll see you again on the next voyage among the stars.